So welcome to Migrating Modules. I guess everybody's awake now. So before I dive into the actual migrating to modules, just a quick FAQ to answer some common questions that come up when I've given this presentation. The first one being, do I have to modularize my application in order to run on Java 9, 10, 11, and everything past that? The answer, of course, is no, and you can actually partially modularize your application, and I'll be covering that in the presentation today. The second question is, will my Java 6, 7, 8 application compile on Java 11? The answer to that question is it actually depends, and it depends upon whether you're using any private APIs or things that you're not allowed to. Will my Java 6, 7, or 8 application run unmodified on Java 11? It depends. It depends upon your use of private APIs and whether you've done anything that you shouldn't have. And how to identify potential problems. There's a utility that's included with a JDK, and it's been included for a while right now, called JDepends, which you can integrate into your continuous integration builds and your regular builds to actually identify whether you will have any problems. So that's just a quick FAQ to get going. So now backing up, the Java modular system goals. The goals with the Java modular system were to make the platform scalable, improve platform security and maintainability, improve application performance, and simplify library creation and application development. Those are the long-term goals. And the two primary ones were reliability and strong encapsulation. With a reliable configuration, this means that you can be certain that when your application starts up, it's going to have all the classes that it needs in order to run. You will not get a class not found exception. You won't accidentally use the wrong version of a dependency for your application just because it appeared on a different part of a class path on a different platform. And also strong encapsulation, the ability to actually hide stuff so that developers and users of your code cannot drill into an API or into an implementation and access stuff that they're not supposed to be accessing. So those are the two primary goals. Why modularize an existing application? One is to firewall software customizations. So if you're deploying an application out to client sites and it gets customized by contractors, etc., and you want to make sure that they can't drill into your software and use APIs or access data that they're not supposed to, modularization offers you the ability to do that. In addition, it enforces good software architecture, so you can't drill around APIs, add dependencies on things that were not expected. And then the third reason for modularization is to create compact deployment images using jlink. And this is the first two are more architectural, everyday development type reasons for going with modularization. The last one has more of a business benefit towards it, in that it reduces your cloud costs ultimately for deploying up on the cloud, for example, as a function as a service, and it also simplifies deployment. So those being the two primary business reasons that I would see for modularizing an existing application. The first two are nice to have and are harder to justify. Migrating to modules. So this presentation is more of a practical presentation. So the first thing you're going to have to do is upgrade your tooling, modularize your existing code, and then generate a package of your application if you're using jlink. Moving past Java 8 will be a challenge today. Modularizing an application is hard, and it's much harder than getting your application to run on a JVM past Java 8. So many applications will run perfectly fine on Java 9, 10, and 11, maybe with little modifications. If you're taking an existing large application or even a medium-sized application and attempting to modularize it, and you've got a lot of third-party dependencies, this is going to be a challenge and may, in some cases, be impossible given the current state of things. So one of the things that modularization solves is Classpath hell. Maven tracks dependencies, but does not enforce runtime. Does not enforce the runtime environment. So there's no guarantee that an application can start and that you won't get a class definition found. It is possible right now on Java 8, and if you're not using modularization, to mix library versions on the class path. So you could have two different developers or two different groups add the same library to different versions of the same library to the class path, and depending upon the order that they appear in the class path will determine which one actually gets loaded, and you can end up with those weird error messages that method not found or errors with class definitions. So that's one of the benefits, or one of the benefits of using modularization. So who should modularize? Well, obviously framework and library projects stand the most to benefit in terms of isolating, being able to project what you want somebody using a library to actually be able to leverage and to drill into. Also customizable applications, so it reduces the chances of Classpath configuration errors. If you have a third-party integrator working with your application, you don't have to worry about them adding a dependency to your application that breaks it or causes bugs. And also preventing illegal customizations. So someone needs to accomplish something and they drill in, they use reflection to access a private API or a private method to change a value. With modularization, that is no longer possible. And then the last one is cloud applications. If you're deploying up to the cloud and you would like to take advantage of jlink and compact images to reduce transfer time, startup time, etc. Java EE and module system, currently there's no support for the module system. It doesn't mean that Java EE application will not run on it. It means that the platform has not been designed for the modular system or what modularization means for Java EE. WARs, EARs are deployed using the Classpath, using class loaders, etc. So if you have an existing web application that you're deploying for Tomcat, modularizing your application will offer you some benefits in terms of architecture, but ultimately when your application runs currently, it won't be running using the module path. JPA, CDI, etc. reflection code is not module aware, which can bring some interesting problems. Containers that are currently running on post-Java 9 include OpenLiberty, Tomcat, just the web container, and also the Jetty, the other container. The other containers, etc., are coming along, and at any point they have Java 9 support. I believe they're pretty close with support for the different ones. So who can modularize today? Desktop applications that are JavaFX Swing can modularize today. Command line applications, non-Java EE server-side applications, and also Java EE applications preparing for the future that want to start enforcing good architecture and cleaning up the architecture of the application. But if you're writing an EE application or anything server-side, you won't be able to actually run with the module Classpath today. So, moving on to tooling. So, one of the topics that's often excluded when talking about modularization is the status of the tools and how you actually set up a development environment. Because I'm assuming that you are going to be developing post Java 8 for most likely 11 at this point, but also having to support applications that are running on Java 8. So you have to support both. So in this presentation, I'm going to cover both Maven and also looking at Jenkins support for that. The first problem that you'll run into when doing development in a hybrid environment or in a real developer's environment is that you have to switch between different JVM versions. There are several utilities out there that make this easy, one of which is JNV, which allows you to have different command windows running different versions. And the nice thing is that it ties in with Maven and Gradle and your different Java build tools so that they're aware of which JVM is being used, right? So that's very important to have your environment set up. I know that some people, will switch back and forth, will have shell variables. This does it at a bit of a different level so that when Gradle starts up its daemon, it starts it up with the right version of the version of Java that you expect to build with. And it offers the ability to switch between JVM versions easily, so you can have one window, or when you're in a specific directory, you're running in Java 8. When you're in another directory, you're running in Java 11. So it makes this process, the development part of the process, easier. That utility was for the Unix platforms. For Windows, you have to use something called Java, which does basically the same thing over on the Windows platform. Makes it easy for you to switch between the two environments, because very often you'll end up testing something on 8, seeing if it works on 11, trying to figure out where your issues are coming from. Tooling support. I've given presentations in the past on modularization. All of the tools are now supporting modularization. That doesn't mean that they support the module system. It means that they will run on post Java 9, Java 11 JDKs, and they're actually able to build. And for the most part, you have to be in the most recent releases of these tools in order to take advantage of that. Jenkins, as I discovered, is not supported on Java 11 yet. So you have to run Jenkins on Java 8. So this is very important to know. You'll get some rather obscure error messages if you do try running it. For doing development where you're going to be compiling code with Maven, you're going to use the Maven toolchain for controlling the JDK version used for doing a build. So even if you're doing Jenkins, you'll use Maven with the Maven toolchain to control it. So the first thing that you're going to have to do with your Maven build in preparation for doing Java 11 modularization work is to clean up and find your outdated Maven plugins. There is an actual plugin that will actually scan your plugins and tell you whether you're out of date on your plugins. That'll be the first thing that you need to do. So if you haven't updated plugins in a year or two, you'll have to take care of that first. Maven uses the JDK and the class path for building. So the source levels that everyone sets controls the compiler flags, not the JDK used to do the actual build. So in order to actually use a specific JDK for doing the build, you need to use one of the more recent features that was added to Maven, which is the toolchain support, where you specify where the JDK is. So don't use the approach at the bottom. Use the approach in the next slide where you set up and define your JDKs in the Maven toolchain file. You specify which one's 11, where Java 11 is installed, where your JDK 8 is installed, and then in your actual build file, you set up the execution to use the JDK specified that are configured in the toolchain. So that's the first thing. So this is trying to tackle the problem of you're still doing development, you're still supporting applications on 8, and you're also working on 11. So moving on to modules. So Java accessibility pre-Java 9. So if we had an interface, a class with an interface and an implementation of the interface, there was nothing to prevent users that are using this package from drilling in and using the interface directly, right? They could directly cast to the implementation, they could instantiate the implementation, they could use Java Reflection to access the implementation, right? So you had you had the concept of being able to lock things down within a class, but then you couldn't lock down a class and prevent somebody from accessing it. So that was one of the challenges: was how do you actually hide the implementation class and force consumers of an API or a library to only use the things that they're supposed to. So with JDK 8, this was the list of accessibility on Java. On JDK 9, we now have this concept of public to specific modules and public only within a module. So now we have the ability to limit things using modularization. Now the modularization system is different than is done at a lower level than class loaders. So if you're trying to compare the Java modular system to like OSGI is implemented using class loaders, so it's still possible to drill in using class loaders and access things. So there's class loader tricks that have been done. With the Java modularization platform, it was implemented at a level below the class loader. So first of all, none of the existing code would break. So if somebody had, extended class loaders or implemented their own class loaders, that code would not break. So the modular system is enforced at a lower level, and it is done so that the JDK itself could be modularized. So that's what's fundamentally different between the Java modularization system and other module systems on the Java platform. It's actually implemented deeper in the JVM, and the JVM itself has been modularized. So for defining a module, you have this new file called moduleInfo.java, which defines a module. Its contents define the following: the unique name of the module, the dependencies of the module, and the packages to be exported for use by other modules. And it's placed at the root of the namespace. So this is an example one right here. The actual full definition of what can go in this file is on this slide here. So this is the full set of keywords, etc., that could possible combinations that can go into this file. And I'll go over some of them as I go throughout the rest of the presentation. But this is the ultimate, the final contents of what the file could actually contain. Module basics: the module names must be unique. Names should follow the reverse domain name pattern. Modules are eagerly loaded. The dependency graph is built and checked on startup, and an application won't start if any of the modules are missing. So this is part of the reliable configuration. So if a module says, I depend upon this other library, and that other library is not there, the application is not going to start up. You're not going to have the application start up and then 4 days later find out that it crashed because the dependency was missing. The module system has no support for versioning, so that's not baked into it. Only one version of the module may be loaded at any given time. Layers may be used to load different versions of a module. So the issue with versioning here, it was not implemented at the module system because that was more than that they wanted to tackle with the platform. But using layers, if you wanted to build a system that did that, you could actually do that using layers. And I'll kind of touch on that in the presentation, but the system itself doesn't do that out of the box. Mainly because then you're trying to control, then you have to somehow tie it into build tools, and that's, exceeds what the many feel that the JDK should be doing. So about versioning, two modules with the same package name in them are considered to be different versions of the same module. So that means you can't have com.your or .util in two different jar files and have those loaded on the module path. The module system won't allow that, and I'll get into how you identify and fix those problems a little bit later. Two modules with the same name are considered to be two versions of the same module. Concealed package conflicts. So when two modules have the same package name in them, the packages are both private in the module, are both private in both modules, the module system cannot load both modules into the same layer. So this is an issue. So if you have, as I said, if you have com.yourcompany.util in several different jar files, and you want to, and you're modularizing your application, trying to put everything on the module class path, that's not going to work. You're going to have to address that. So, modularization process. So, the first step in the modularization process is to use JDEPs to understand where your application is right now and what you actually depend upon. That goes in with identifying dependencies, refactoring your code. So, generally, if you're modularizing, you have a large application, you're going to end up having to fix splits. You're going to have to look at reflection code that you're doing. Are you reflecting on stuff that you're no longer going to be able to access? Are you, using that to defeat, public-private stuff in the Java language to change a method and change a value of something in a class? And also, you'll probably, to fix some of the issues in your code, you probably have to adopt services, which I'll be covering. And then finally, if you decide to go with the jlink goal, the thing to realize is that in order to use jlink, everything must be in a module, including your third-party dependencies. So this is what's often, not covered in discussions of modularization. It's held up, jlink, you can create these super small images which just contain your code and the JDK and your dependencies, but what's missing is the fact that in order to use jlink, your application has to be modularized, and all of your dependencies that your application use have to be modules as well. And that's a pretty tall order right now. And then finally, create the actual module files. So the JDK allows non-modular code to run on modular JDK. So that's why I said an existing application. Taking an existing application and running it on Java 11 is not that big of an issue. Modularizing an application is a major issue. The boundary between modular and non-modular code can be moved, which means it can have an application partially modularized and be working towards modularization. So it's not a binary switch that you have to modularize the application and fire it up for the first time to see if it works. You can modularize parts of the application and take that approach. The path the jar file is placed on determines whether it's on the module path or whether it's a module or not. So the module path, there's a new parameter that was added to the different command line utilities. If you put it on the module path, it's loaded as a module. If you put the same jar, even if it contains module info on the class path, it is no longer a module. It's behaving like it did before in the Java 8 and earlier days. So the simplest approach with modularing an application, if you have a Maven setup for your application, is to make each one of your Maven modules a Java module itself. So for each one of those, I'm going to export, net.cuprak.demo, explore, profiler, etc. util. Right. So each one of those becomes those are the module names. So each one of those becomes a module. That's the simplest approach, and the approach that will probably work for most of you. JDEPs, as I've alluded to, is a command line utility which is included with Java 8 and later. It was updated in Java 9 with additional parameters. It is a static class path checker. It generates a module info file for you. And the key features are it analyzes for dependencies on the JDK internals, analyzes class path module dependencies, and also can produce configuration and visualization files. So you've probably seen in presentations on Java modularization those graphs, right, with the showing the dependencies within the JDK. It was actually generated using JDEPs. So the command line parameter for JDeps. It outputs, in this case right here, this will output a module info.java, and then you can take and copy that module.info.java into your source path. So this is how you make the initial crack at generating your module info.java, is you can use JDeps to bootstrap that process and get it moving along. Okay. JDeps, as I mentioned, can visualize dependencies of a jar file. So in this case, I'm running it against the jar file. It prints out the dependencies, and I can have it output .dot files. Now you might be wondering, okay, well, how do I visualize a .dot file? There is a utility in the Unix community called graph-viz, which will read in those graphs that are outputted by JDeps and generate this. So this is a quick and easy way that you can use JDeps to analyze your existing dependencies to generate a graph that will show you what your application looks like, so that you can show it to upper management, and develop plans off of that, etc. The JDeps, there's also a Maven plugin with it that you can add into your continuous integration build today. So if you're still on Java 8 and you haven't made the move past Java 8, you can include this. So you can start analyzing that. And also tools like IntelliJ have a DSM dependency matrix tool, which will allow you to see the dependencies from different parts of your application. Because depending upon how large your application is and how old the code base is, you're going to need to visualize and understand the relationships between them. And this tool will actually show you what the real relationships are, not what just what your documentation that was may have in it. So modularization challenges. So the challenges are removing dependency cycles, which you can address using the services stuff to break cycles, which is the reason why it was added. Refactoring split packages, addressing missing Java EE dependencies, because Java EE libraries from Java EE that were included in the JDK in the past are now removed, such as Jaxb, so those are no longer there. You'll need to update reflection code, exposing transitive dependencies, which I'll cover in a second, and also refactoring for a service, which factors into addressing cycles. So one of the things with a module system is that you can no longer have cycles. So in this case right here, I've got org-ct-java.model, which depends upon util, which depends upon base, and so we've got a cycle between these two modules. They both depend upon each other, and given how things are compiled today, this may compile perfectly fine and run fine. But if you modularize org-ct-java.model and org-ct-java.util, the modular system is not going to be happy, because there's a circular dependency between the two of them, because you can't have this guy depending upon this guy, they're both depending upon each other. That also extends to a more complex case where you've got a larger circle going around in your module graph. So in this case, this will also break. So the solution to this problem, which I will cover in a couple of slides, is to use the service provider API, service provider stuff that they've added. That is how you break cycles, is you use the services. In addition, as I've mentioned multiple times already, you can't have split packages, so you can't have the same package existing in two different jars, even if it is not public, even if you're not exposing it. So you're going to have to refactor the code and either move code around in order to address this concern. Refactor the packages or move the code, one or the other. So you're going to have to refactor it. So in this case right here, you can see I've got Explorer, Profiler, Util. Both of them have this util package. One of them is there's going to have to be some refactoring done in order to handle this. There is a open source plugin which you can run over your existing source code base, and this will do the analysis for you to tell you where your split packages are, right? So as opposed to sitting there in the IDE and scrolling through all the list of packages, this tool will go through your existing source code base and tell you where your split packages exist. So this is a good one to integrate into your build. Java EE dependencies, if you're depending upon any of these for an application and you're not deploying to an application container, you're going to have to get actual implementations of these and include these with your application if you're running now on post Java 9. So this depends upon, if you're running on Java 9 or 10, you can just use add modules. If you're running on Java 11, you're actually going to have to get something in order to run it. Reflection. So in this case right here, this is an example of reflection. So I have a admin module which depends upon JavaFX Controls, And so my module said, my module definition for the admin module, I say I depend upon JavaFX Controls, I require these other services, and I go to run that application and it blows up. And the reason why it blows up is because JavaFX Controls is doing reflection on my classes in org ctjavaadmin as a part of it when it starts up the initial stage and everything, etc. So this is a really simple example that you can hit out of the box. And so you have to, so the JavaFX graphics tried to instantiate the admin console app because it tries to start up the application and it failed. So in order to do this, you have to say, well, I'm exporting org ctjavaadmin to the JavaFX graphics. So in my module, I'm giving this other guy, this other module, permission to do reflection on my code. So I can use the JavaFX stuff, but it can't depend upon me. It can't do reflection on my stuff, so you have to handle situations for that. So when I say that you have to look through your reflection, you have to understand what you might be reflecting on and how that might be impacted by modularization. So nothing changes for reflection code performing read. So if you're just doing reflection with like reading stuff, that doesn't change. You can search for modules and reflect upon them. So there have been some changes to the reflection API to add support for being able to reflect over modules, see modules, and then interrogate them. And you can use, if you're dealing with some of the more complex cases with reflection, where you're trying to pass down reflective access, you can use something that was added in Java 9 called var handle for handling this. So this is more of an advanced topic, but if you're doing more in-depth stuff with reflection, look at var handle. This might make your life a little bit easier. Module graphs. So there's this concept in the modularization system called a module layer. It comprises a fully resolved graph of modules. Class loader is used to load the module's classes. Each loader has an unnamed module associated with it. And so there's an actual, if you look at the starting in Java 9, you have this new class called module layer, and it's got methods which return the modules in the layer, it allows you to find modules, examine parents, find the loader, etc. And so where this came in is if your application is doing any sort of like plugin type stuff where you allow somebody to write code and then you load it as a plugin, like in IDEs have plugins that allow you to load plugins. Well, if modules have to be resolved when the application starts, then how exactly do you dynamically load code at runtime to implement like plugins? Well, in order to do that, you use the module layer stuff to actually do that. So this code right here creates a module layer and loads code dynamically. So the code that's loaded dynamically is still modules, it's loaded on a different module layer. So when the application starts up, the application module layer has to be finalized, all the dependencies have to be resolved. But then if you're trying to dynamically load code, then you have to create another module layer in order to instantiate it. Transitive dependencies. So in this case here, this is kind of a different way of thinking about code. I have my admin module, which depends upon services, but it has a transitive dependency upon model because methods in services expose some of those classes. So this is what I mean by a transitive dependency. And you have to take this into account when you're defining your modules. So in the meeting interface, which appears in org ctjava services, it uses meeting from the module class. Now, because org admin ctjava doesn't depend upon module directly and doesn't have access to it, if you do not set up transitive dependencies, the code, you won't actually be able to instantiate or use those classes. So in this case right here, the solution for this problem is to use requires transitive, and so I'm now saying that org ctjava admin, so I'm exporting from service. So in the services module, I'm saying whoever uses me can also access this other module. So they're going to need access to this module in order to use my module. Services it was an API first added in Java 6. It has rarely been used outside of the JDK, and it was enhanced, altered for Jigsaw. And the reason why it was enhanced and altered was to help you to be able to solve the problem of circular dependencies. So you can move things that were circular dependencies off into services which can be loaded. So this is an example here where I've got messaging API, and I've got an implementation of it, right? And so when you start up the application, you provide, the implementations of the service, and then it can be dynamic, then it can be invoked. So I have my message service, and then the API for it, so I'm detailing what I'm exporting, and then the actual implementation of the service, where I'm specifying up at the top, that provides is the keyword over there on the left. I'm specifying that I'm providing this service with this implementation. So this is implementing services. And so there's more advanced, you can go out and look at more examples of this, but this is how you deal with the issue of circular dependencies between things. You'll move things that were circular dependencies off into services. And so this is services in action here, where I'm actually depending upon a service that's loaded on the class path, and I can actually loop over services. I can find out if there's more than one implementation loaded for a service, and then make a decision as to which one to actually use. Now, for troubleshooting problems, very often you'll run into problems with modularization, trying to understand why things aren't working, why you're getting errors, and there are several different commands that you have for actually troubleshooting it. So you can use the describe the module and pass in a file in the jar file. You can do a dry run. You can have it show you how it's going to do module resolution. So you've got several different options. So these are your friends for figuring out why or if something is not running as correctly. JLink. Moving on to JLink. So JLink generates a runtime image including the JVM, and so this is one of the touted features of modularization, right? That you can take this and create this compact image of your application, which includes just your application and the minimal parts of the JDK that are required to run your application. It also generates scripts for invoking your application, so it'll put a startup script in the bin directory, which will actually launch your application with the name of your application, right? So this simplifies if you're having to deploy your application up onto the cloud, up onto servers, onto desktops. This makes it much easier because this is a very clear way of just deploying something. Even a small JavaFX application, I think, only takes up like 70 megs, with JDK dependencies. So the basic invocation, so only the required modules are included. The basic invocation is down at the bottom where you pass the module path, add modules, etc. And so, demo application using, all the features of JavaFX is only 95 megs, whereas the full JDK is 454 megs. And if you weren't using JavaFX, it shrinks down even more. So you can have substantially smaller applications. So as I mentioned, if you're doing stuff with functions as a service up in the cloud, where you want to have a minimal startup times, you want to have a minimal size of an image and a minimal amount of memory used, JLink is your friend. However, this only works with what are called named modules, which means that everything has to be modularized. So all of the jar files must have a module info.java in them, including your dependencies. So if you depend upon Hibernate, Hibernate has to be modularized, right? It has to have module-info in it, right? Not supported, so unnamed modules and automatic modules are not supported. So you can take an existing jar file and add it to the module path, and the jar file's module name will be the name of the jar file. There's some rules around that, right? But you can do that for running applications and putting stuff on. But as soon as you want to use JLink, you can't use automatic modules. You can't have it auto-generate the module name from the name of the jar file. The jar file actually has to have a module info within it. So you've got several different options. One is the Maven JLink plugin. So this is what will actually generate a JLink output for you from your Maven build file. So obviously you're not going to put in JLink command line option in your Maven build. You're going to use a Maven plugin, and so this is one of the key ones that you would use for generating JLink. So as a part of your Maven build, you'd include this plugin in order to generate JLink output, assuming that all of your dependencies have been modularized. So the other thing to look through when looking at dependencies, so as I mentioned, many dependencies are not modularized. And so generally what you'll see in, like in the IDE is going to pop up and tell you that you have to import the module as a part of it. And in this case, this one right here, I believe, has metadata associated with it. So when I first tried using Commons IO, the IDE suggested that suggested that I use this particular import, and I looked at the package name and I said, well, wait a minute. The jar file, I thought this was operating as an automatic module, and that wasn't actually the case. So the jar file name was this. I thought it was going to be this based upon the jar name, but the IDE instead inserted that. And the reason why is that it looked at, there was a manifest entry that was added, which has basically where the author of the library has reserved, even though they're not providing a module name, there's something that's been added to the manifest, which basically is reserving their name for the module. So this is going to be very important for the next part of the next couple of slides where I cover how to modularize things that aren't modularized yet. But you have to be aware of this, that you might declare a dependency on something. You think that it's using automatic module names, but it's actually going to pull it out of the manifest file. And if you notice this stuff is OSGI. This has nothing to do with many of the open source projects also generate stuff for OSGI. So when you look at this, realize that you're going to have OSGI stuff in there, so don't get confused between that and the Java modularization system. So jlink requires module info.java and all jar files. You have two solutions for this problem. You can hand create module info.jar files for each non-modularized dependency, repack the jar file during the build process, and then after the build process, alter the build process to include the repackaged jar files on the Java-C's Classpath. So this is actually quite a bit of work. The second approach is to hand create module info.java files for each non-modularized dependencies, repack the jar file, publish it to your company's local Nexus Artifactory repository so that your Gradle Maven build works as expected, so they don't have to make any changes to the build. So there's really no good solution right now. So if you have a third party that doesn't have module.info, you want to take advantage of it, there is no good solution. There's only two, bad to worse solutions. There's either, both of them involve repackaging the jar file with module.info. One, you're going to mess with the build system to get it included as a part of the build, mess with what Maven is doing during the build. The second approach is to publish it to Nexus and just hope that nobody else adds in a dependency on a newer version of it which doesn't have that, which then fails the build, etc. So the build repackage solution, large builds will run much slower, obviously, complicates the build configuration, and in my work with that I ended up having to use -X a lot to troubleshoot things and try to figure out where things were going wrong. The Nexus Artifactory solution, you end up with frozen dependencies, so now if somebody wants to use the newer version of a dependency, you're going to have to repackage that jar file to deal with it, and it obviously requires manual intervention. So the good news is that this is temporary, and hopefully vendors will modularize. Now the solution for repackaging stuff on the jar as a part of your build, there's actually a plugin that will do this for you right now, a Maven plugin. It's called Moditech plugin, and it repackages dependencies during the build process. So this is, during the build process, I'm specifying that commons.io, and in the module info source, I'm providing the contents of the module info source for it. And so what this plugin is going to do is at the end, it's going to repackage commons.io, the jar file, add in the module info that I've generated for this. Now I could have generated this using JDeps, then pasted it over into this file. That'll be your workflow. You use JDeps, paste it into your build file. Then you're going to have to make sure that that automatic module name that I mentioned before that was in the manifest lines up with the one that you choose to go in there, because otherwise the IDEs won't work correctly. The first time I did this with Commons.io, I picked what I thought was going to be the name, and then the IDE refused to see it. So if there's an automatic name in there, you're going to have to, if there's a name, if the author has reserved an automatic module name, you're going to want to honor that. Okay. And then tying into the compiler build, you're going to have to add the stuff. You're going to have to add this module path and add the directory to it where you've placed your now mangled jar your third-party dependencies, which you've mangled and added the module info to. So you're going to add those. So this is how you get those onto the module path, so everything else downstream of it works, right? So the first thing that's going to happen is you're going to repackage your third-party dependencies with the module info that you've created for them, and then you alter the build process so that it's able to find them. And then this block of code here, as a part of jlink, you can actually provide running the ant part of it to actually build the actual jlink file. So on this next slide right here, I'm actually building up, I'm using the Moditech plugin once again, so you create a separate module for your separate module in Maven for the jlink portion of it. So you have all the modules. So you'll have all the modules of your application, and then you'll have a separate module for mod jlink for generating the output, for generating the jlink output of your jlink image of your application. So this is the configuration right here where I pass in the Moditech plugin, declare my dependencies, etc. And then more configuration of that, specifying where the modules were previously generated. The launcher specifies the name of the launcher that I want to create, so it's going to create basically a shell script for me that's now going to specifically launch my application, in addition to providing the link in there for the JDK. And the thing to realize when you're going through this process is that some things may be modularized already, so some of your dependencies, transitive dependencies, and may already be modularized, so this is a non-trivial task. One of the things that I tried to tackle with this presentation was I looked at actually trying to modularize the Eclipse link, sunk about 5 hours into trying to modularize that and trying to get the module infos to work correctly. So that's why I said that this is not necessarily a trivial process. So in terms of best practices, don't publish dependencies using automatic modules without an automatic module name in the manifest. So if you're running Nexus internally, or you're maintaining an open source project that you're publishing to Maven Central, you need to do this immediately, where you publish, at least put it in your, if you're not providing module info.yet, make sure to at least reserve the name for your module so that people don't start depending upon the name of the jar file as the module name if they're modules of their application. Don't remove exports from a module in a future release, so this breaks backward compatibility. And keep module infos clean, so don't add in unnecessary dependencies. And the other thing was avoid using qualified exports where you export stuff to a specific module. And remember that if you're maintaining a library today and you add a module.info to your library, that does not mean that somebody that's using your library has to be using the module system at all. They can still be running their application on the Classpath. However, those that are attempting to write an application or attempting to modularize their application will benefit from that because it'll make their job much easier. So, in summary, Java 2.DE are not aligned with modularization yet, and obviously that's something that has to be addressed and figured out how that's actually going to work. Modularizing an existing code base is hard. You have to deal with split package removal, reflection code update, plugin logic. Jlink is awesome. It's one of the the major features that's been touted for modularization. But as I mentioned, all your dependencies must have a module info.java, and the solutions for dealing with dependencies that don't have this yet are messy and time-consuming. So, in summary, lock down your APIs, no casting the implementation, no accidental dependencies. So the modularization benefits: you sandbox application code, prevent class path corruption, control application customization, small runtime images, so you get the self-contained JREs with your applications, which ultimately, if you're doing cloud-based functions as a service, will reduce your costs. So with that, some of the links are up there. There are several good books that are out on it now. So the tooling is much better than it was a year ago. So a year ago, these plugins for dealing with, for analyzing split packages, for fixing jars, for fixing third-party dependencies that didn't have module infos, didn't exist. So we've moved a lot further from last year, and you have a lot more. It's much easier to modularize your application, but it's still a tall order. So if you're looking at this right now, there's a long road ahead of you. So thank you.